Dear aspirants, hearty welcome to ESE Engineering Academy online platform. ESE Engineering Academy offline students. This program is intended for preparation strategy for engineering services and GATE 2024 regarding the subject of irrigation engineering. If you refer to this, in GATE, on the average 2 to 3 marks, not more than 4 marks, at the maximum 4 marks. Sometimes even they are giving 2 marks also, but most of the times 2 to 3 marks, either the morning session paper or evening session paper. If you take ESE prelims, (15 to 18 marks), sometimes maximum of 25 marks. If you take ESE mains, maximum 30 marks. You can understand, for GATE, irrigation engineering is not a scoring subject. For ESE prelims and ESE mains, one of the most prominent, as much important as fluid mechanics, as much important as geotechnical and environmental engineering subjects. Approximately I have given. Slight variation may be there in the actual paper. It all depends on year-wise team of the paper setters. This is mainly intended for GATE paper. Let us see. If you refer to the GATE examination, basics of water resources engineering, basics of water resources engineering, soil, water and plant, water requirement of crops, quality of irrigation water, quality of irrigation water, design of lined canals, design of unlined canals, canal regulation works, diversion headworks, gravity dams, friends. As far as GATE exam is concerned, these are the 10 topics that are there in the syllabus. How to prepare, what type of strategy you have to develop, because time is just 1 month, 1 week, exactly 5 weeks. And we won't find much time for irrigation engineering generally. I advise you to be thorough. First preference, second preference, and third preference. Please go through these 3 chapters: synopsis, logical questions, level 1, level 2 problems, and PYQ. If you are writing only gate examination, if you follow these, if you prepare these 3 chapters, 3, 6, 9 chapter numbers, I am sure you will get that 1, 2 marks or 3 marks very easily. 95% of the situations, they will give the questions for gate examination in these 3 chapters only. Generally, in the water requirement of crops, before we see what type of questions are asked, let me give about ESE also. If you go for ESE examination, both prelims and mains, if you go for these 1 to 9 chapters of GATE, apart from that, 10th chapter, river training works. 11th chapter, earthen dams. 12th chapter, sediment transport mechanism. 13th chapter, reservoir planning and basics of water power engineering. 1 to 10 chapters. Sorry, this is 1 to 10 chapters. When you go for engineering services, which chapters are important? I am telling you in advance, all 14 chapters are important. If I refer to any of the previous papers, there is no single chapter left untouched by the paper setter, because they are giving around 15 to 18 questions. Every chapter, one question, that way or this way they will be covering, either theoretical or numerical or logical. So please remember, for ESE examination, there is no choice. For ESE examination, irrigation engineering is one of the most important subjects. Bolna mat. If you forego irrigation engineering, major part will be lost. Don't neglect irrigation engineering if you are writing ESE prelims and ESE mains. If you are writing gate examination, there will be nothing like too much harm if you just skip the subject. I repeat, there is nothing like too much harm. Nothing like too much harm, too much loss, even if you skip the subject of irrigation engineering for gate examination. Reason is very simple. Weightage is very, very less. Out of 100 marks, 1 mark, yeah, 2 marks, maximum 3 marks. 3 marks is sometimes rare. 2 to 3 marks. You can see even by fluke, even by having a glance, having a overview within half day time or within 1 day time out of your serious preparation. If you allot 1 day, cover those 3 chapters. What are the subtopics? I will discuss one by one. Water requirement of crops, design of unlined canals, and gravity dams. These 3 areas are very, very important for your examination gate. In these 4 chapters, 10 chapters are equally good. They are asking lined canals. They are asking unlined canals. Yeah, one more is there. Extremely sorry here. Water logging and drainage. One question gunshot in this. Water logging and drainage. 5 years back it was there in GATE. Also, in the recent years, water logging and drainage chapter has been removed. Anyway, for GATE you need not touch that chapter. And 1 to 15 chapters, you must make yourself ready for ESE prelims, gunshot selection, ESE mains gunshot selection के लिए you have to thorough with all the 15 chapters. How to prepare? What is the preparation strategy? For GATE I am telling. Go through entire synopsis first. Go through the entire synopsis first. All the 10 chapter synopsis. You might have the class notes. You might be having the printed material given by the academy. First have a glance of the entire material in your preparation time, I am telling you. Then PYQ GATE only last 5 years. Irrigation subject में, in the irrigation subject, in the last 5 years, what are the questions given? Must and should visit that. Only last 5 years questions. Then practice important models from 3, 6, 9 chapters. Water requirement in these 3 chapters, don't leave anything untouched. Masterize these 3 topics without fail. Water requirement of crops, design of unlined canals in alluvial soils, and gravity dams. Preparation of short notes makes revision very much easy. Revision very much easy. So, go through the synopsis. PYQ gate questions of the last 5 years only. Whatever important chapters I have given to you, 3rd, 6th and 9th chapters, there's practice A to Z important questions including logical questions, numericals and theory questions only from those 3 chapters. Preparation of the short notes. When you prepare the short notes, subject-wise, including irrigation engineering, already you might have prepared right from the starting point of your coaching time. Whenever the subject is over, it is a general habit of the student community to prepare short notes. If you read 10 pages, if you write 10 pages notes today, you will write within 1.5 page. If 150 pages notes is there, further you will be preparing about 10 pages short notes. What is the use of the short notes? You can revise as many times as you can. The more the number of times you visit and revisit the short notes, recalling of the basic formulas, recalling of the basic concepts, that will make you stronger and stronger when you are attacking the numerical problems. That's why preparation of the short notes also. I repeat the 4 steps, my dear friends. Go through the entire synopsis first. When you plan to start, already might have finished off this first part and second part. Go through the entire synopsis. When you start preparing the subject of irrigation engineering for GATE, I am telling you, PYQ GATE, only last 5 years copy I, practice important models, all numericals related with the 3rd chapter, 6th chapter, 9th chapter. Don't forget to revise. Preparation of the short notes makes revision very much easy. After preparation, revise the short notes as many times as you can. Revise the short notes as many times as you can. I am sure by doing these 4 steps, review of the entire synopsis, PYQ GATE questions, practice important models from the most important chapters, preparation and revision of short notes as many times as possible. If you see the subtopics for ESE examination, my dear friends, for ESE examination, be thorough, with subject by referring to the textbook of S.K. Garg. I recommend S.K. Garg book for this. Institute material, ESE PYQ book, be thorough with all conceptual questions and numericals. First of all, go through the subject of all chapters, 15 chapters. I told you there are 15 chapters for ESE examination. गेट एग्जाम के लिए 10 chapters, ESE के लिए और 5 chapters extra. All 5 chapters are important. They'll give a question definitely on reservoir planning, water logging, tail drains, spacing of tail drains. What do you mean by drainage coefficient? Such questions are commonly asked. Sediment transport mechanism at different layers of the canal flow. How do we have the variation of the concentration? When can we have covering of the particular soil particle from the canal bed and side slopes? Sheets, theory of transport mechanism of the silt. The two concepts are very, very important. Earthen dams, types of earthen dams, failure of earthen dams, how to get the protection, that is also very important. In river training works, marginal embankments, guide banks, supporting banks, different types of spurs and groins, artificial trenches. What do you mean by meandering? Meandering length, meandering width and width of the river, the mathematical relations in terms of discharge. Don't forget, meander length ML, meander width MB, width of the river W, all three are directly proportional to square root of discharge. What is meant by meandering? How to control meandering? What is the degree of tortuosity? I am just telling you the different subtopics you have to prepare for ESE. For ESE examination, irrigation engineering syllabus becomes ocean. Make selective reading for GATE examination. Make comprehensive and exhaustive studies for irrigation engineering for ESE prelims and mains. The weightages to be given are like this. For GATE only this much weightage. For ESE this much is the weightage. Please. Strategy is important. How to prepare, with what strategy you are going to prepare. How much importance you are giving while preparing. That alarm must be there in your mind. This is very important. The subject is very important. In these topics are very important. 2022 you have given. 2021 2 times it is given. Both prelims and mains. Like that you should have that idea in the mind. All questions must be lingering in the mind. Then only will be moving towards greater and greater, better and better success. Please remember this. As you can see from this, preparation strategy of GATE, preparation strategy of ESE, that is very good. First we will see the water requirement of crops. What are the sub-areas? Because these are equally important for both GATE and ESE. Most important for GATE. For ESE, there is nothing like unimportant, I told you just now. In water requirement of crops, delta, base period and duty relationship. What subtopics you have to give weightage, I am just giving you. Delta is equal to 8.64 B by D, 864 B by D, 1.98 B by D. Frequency of irrigation is equal to dW by Cu. What is the time interval between one watering and the next watering? Time gap between 2 consecutive waterings is called frequency of irrigation. It depends on specific gravity of the soil, root zone depth, field capacity and optimum moisture content divided by consumptive use. The 5 types of efficiencies are very important, sir. Water application efficiency, water conveyance efficiency, water irrigation efficiency, water use efficiency, water distribution efficiency. Water consumptive use efficiency, like that, they are not that much important. Please practice these 5 formulas regarding water efficiency. Water application efficiency, that is in the field. Water conveyance efficiency in the canal. Water irrigation efficiency overall. Water use efficiency in the field including leaching. Water distribution efficiency, that is statistical efficiency. Statistical efficiency. Then we should know FIR, what is consumptive irrigation requirement, net irrigation requirement, field irrigation requirement, gross irrigation requirement. Then you must know what is intensity of irrigation. Then you should know fixation of line discharge of the canal. Fixation of reservoir capacity. These are the subtopics. You have to concentrate while you are preparing for GATE from the chapter of water requirement of crops. Relation between the 3 water requirements, duty, delta and base period, their definitions, relation like dW by F is equal Cu by 1 is equal delta by B, such strategic formulas, very, very important. What are the factors affecting duty? At what points with what name duty as is being called? How do you improve the duty? How do you improve the duty? By crop rotation, etc. These are the water requirement of crops, most important ones. In the design of unlined canals, what are the causes of silting and scoring? Kennedy's theory. Its drawbacks. Lacey's theory. Its advantages and drawbacks. Canal losses. We know evaporation losses are minor losses. Seepage losses and percolation losses are major losses. Around 2 to 3% is evaporation loss. Around 20 to 30% will be seepage and percolation losses. Something about the losses also must be known. Speciality of Lacey's theory. Importance of Kennedy's theory. what is the critical differences between Kennedy's theory and Lacey's theory? Generally, they will ask you. Non-silting, non-covering velocity is a function of is a function of what parameter in Kennedy's, what parameter in Lacey's. In Kennedy's, it is the depth of the flow. In Lacey, it is the hydraulic mean depth. In Kennedy, V0 is equal 0.55 m d power 0.64. So, critical velocity is a function of depth of the flow only. Whereas in the case of Lacey's theory, critical velocity is given by root of V is equal to root of 2 by 5 Fr. R. So mean velocity or critical velocity is a function of hydraulic mean depth in the case of Lacey's theory. What are the advantages? What are the drawbacks of Lacey's theory also you must understand. Their mathematical formulas. In Lacey's theory, how many are fundamental equations? How many are derived equations? What are the graphs drawn between various parameters? Basics of mathematics in solving the questions also important. Then in the third chapter, in gravity dams, what are the most important subtopics? Water levels in the reservoir, water storages. What do you mean by limiting height? Fixation of a freeboard. What is the use of the limiting height to decide whether the dam is a high dam or low dam? What are the different water levels? What are the different water storages? Surcharge storage, live storage, dead storage, valley storage, and the bank storage. The 5 storages, 4 water levels are important. I hope you know pretty well. Limiting height will decide whether the dam is a high dam, whether the dam is a high dam or low dam. If H is more than HL, high dam. If the actual height of the dam is less than or equal to HL, low dam. You must understand the points. Forces acting on a gravity dam. Moments of the forces. P1, P2 water forces. Self-weight and uplift force are vertical forces. PS, PW, silt pressure force and wave pressure force. Special conditions. In the seismic zone, force due to earthquake. In the Himalayan region, force due to ice pressure. Total 8 forces. We consider 6 forces. If major forces are 4, P1, P2, W, U. Minor forces are only 2, PS and PW. You can get this very easily. After this, what are the modes of failure? modes of failure, sliding failure, overturning failure, compression failure, and tension failure. How to decide whether the dam is safe in all the four failures or not. In sliding failure, we got FSS, we got SFF also. Factor of safety against overturning, sum of the stabilizing moments by sum of the overturning moments. How do you check whether the dam is safe in compression or not? The maximum compressive stress, if it is less than F, permissible compressive strength of the concrete, then the dam will be safe in compression. Otherwise, the dam will get crushed to powder. E value less than or equal to B by 6 for the dam to be safe in tension. In other words, it is called middle third rule. Line of action of the resultant of all the forces should fall within the middle one-third of the base. Within the middle one-third of the base. Then how do you calculate the principal stress? Principal stress at heel, principal stress at toe, shear stress at heel, shear stress at toe. Whatever we are learning, we apply to the elementary profile also. Of elementary profile is very important. Moment the design bed width will be greater value of H by mu into S minus C, H divided by root S minus C. To be safe in sliding this one, to be safe in overturning called stability, minimum bed width, whichever is the greater value, we must provide in reality in the construction, bed width of the elementary profile must be kept as the greater value of these two. In the absence of uplift, B design will be greater value of H divided by mu S, H divided by root S. When it is given without uplift consideration, calculate the two values, whichever is greater. So this particular area, definitely you can expect one question. Definitely you can expect one question. Attached with the gravity dams, we got spillways. Ogee spillway, siphon spillway are important for us. Ogee spillway with Ogee profile with effective length the three formulas in Ogee profile. First formula will give the discharge. Second formula will give the Ogee profile on the downstream side. Third formula, how do you calculate the effective length of the crest in case of Ogee spillway? In case of siphon spillway, Q is equal, area is L into B, velocity is root of 2G into H1 plus H2. Amount of water being disposed of through each siphon is given by this. If you want to send more water to dispose of more discharge, two or more siphons must be connected in parallel. In gravity dams and spillways, these are the subtopics. In ESE examination, of course, in one gate exam also they asked about the energy dissipators. There is also equally good area. Energy dissipators. By mathematical equation, you get JHC in the real field. So TWC real field JHC mathematical. By mathematical calculation, with what height the post jump depth will be y2 versus q, real field TWC, mathematically JHC. This is real field. This is hydraulic jump calculation. Depending upon the relative positions of JHC and TWC, we got 5 types of energy dissipators. If TWC coincides with JHC, horizontal sloping apron. If TWC lies above JHC, we provide sloping apron above the riverbed. If TWC lies below JHC for all discharges, below JHC, TWC lies below JHC, sloping apron below the riverbed. If in a special case like this, TWC, JHC, Y2, Q. For small discharges, TWC lies below first half of the sloping apron below the riverbed. For higher discharges, TWC lies above JHC. So the second part of the, if it is a total 6 times Y2 minus Y1, first 3 times Y2 minus Y1 below the riverbed, next 3 times Y2 minus Y1 above the riverbed. Easy way to remember. In what situation, what type of energy dissipator is to be provided. Just have a gist in the mind, revise once or twice before examination. They are only memory based. How, when the jump will be, when the hydraulic jump will be drowned in the water. All these things practically you cannot think that much time in the exam. In what situation, what type of energy dissipator is provided, that is important for us. And uska reverse. For small discharges, TWC lies above first half of the length of the sloping apron above the riverbed. At high discharges, TWC lies below. Naturally, sloping apron will be below the riverbed for the second part of that. All 5 cases will be there. You should remember, they may give in match the following. They may give the reduced levels and ask for this type of data available in the field, what type of cross drainage, what type of energy dissipator you are going to provide. Please remember this. One more most important area is cross drainage works. You should know aqueduct, siphon aqueduct. These two comes under type 1 cross drainage work. Super passage and canal siphon, they come under type 2 cross drainage work. When do you get type 1 cross drainage work? Immediately your mind should recall the points. Q canal less than Q drain, Q canal around 20, Q drain around 200. 20 cubic canal water runs at higher elevation at the junction. Drain water is permitted to go on the ground, type 1. If a canal discharge 200, drain discharge 20. Drain water is permitted to go to the higher elevation and come back, that is type 2. If a canal runs over the drain, type 1. If a drain runs over the canal, type 2. If both run at the same elevation on the ground, type 3. We never come across type 3. Type 1 without siphonic action, aqueduct. With siphonic action, siphon aqueduct. Type 2 without siphonic action, super passage. With siphonic action, canal siphon. These 4 problems and theory. In Monday's class, we'll solve 1 or 2 problems. Also, we'll be discussing the very important 4 figures. You must practice. They may ask a figure. They may ask a descriptive question. Cross drainage works is one important area. They may give a numerical also on this. In canal regulation work, one more important is canal modules. When do you say rigid module? When do you say semi-rigid module? When do you say non-rigid module? The definitions and their mathematical formulas are important. Simultaneously, when you are preparing the canal regulation works in canal modules, what is flexibility? What is proportionality? What is sensitivity? And what is setting? These four definitions, their mathematical formulas, they are very, very, very important. The first chapter generally, I'm telling about methods of irrigation, and the basics of water resources engineering. They will ask on methods of irrigation. When do you go for furrow irrigation? Furrow irrigation. When do you go for sprinkler irrigation? When do you go for flooding? What is the advantage of border strip irrigation? In the border strip irrigation, 2 formulas are important. What is the time required to irrigate a field? T is equal to 2.303 Y by F log Q upon Q minus FA to the base 10. Maximum area that can be irrigated without any external storage. Most important formula of the chapter is maximum area that can be irrigated is equal to rate of supply of water divided by rate of infiltration. This area also very good area. In the fourth chapter, quality of irrigation, only one point is important. What is the sodium absorption ratio? Sodium ion concentration by square root of calcium ion concentration plus magnesium ion concentration by 2. If at all they give the question on the quality of irrigation water, I am telling about both GATE and ESE. Gunshot, they will give on SAR. SAR value 0 to 10, 0 to 10 S1 water, 10 to 18 S2 water, 18 to 26 S3 water, more than 26 S4 waters. Low sodium, medium sodium, low sodium, medium sodium waters preferable. S3, S4 waters are having high sodium. They are not permissible to get delivered to the field for the purpose of irrigation. Lined canals, generally they will ask about hydraulic mean depth formulas only. That is not much important. And gravity dams, spillways, diversion headworks. There is one area where in ESE examination, very important topic is the diversion headworks. What is the difference between weir and barrage? What are the seepage failures? When you construct a weir or barrage across a river, what type of, there are 5 failures. Failure due to slowing action, failure due to standing wave formation, failure due to rupture of the floor, failure due to uplift pressure, failure due to piping or undermining. Then, to prevent or control failure due to piping, what is the importance of Blaise theory? With what modifications Lane's theory is developed? With what revolutionary statements cost loss, exit gradient theory is coming in practice? A सब टॉपिक्स के बारे में थोड़ा सा प्रिपरेशन करना होगा. This is very, very important. And have the smart way of preparation. Don't forget preparation of short notes. Don't forget preparation of short notes. Numericals practice करते समय don't try to use virtual calculator. Try to get the nearest value. Identify what is the answer given. Revise all the numericals, all the related mathematical formulas to the extent possible. Whatever subtopics I told, please go through them. For example, in cross drainage work, in which of the following situations worst uplift will happen? Uplift pressure will be maximum, means worst uplift. When does it happen? Under what? In case of siphon aqueduct, in case of canal siphon. In river training works about the meandering. Lacey's wetted perimeter P 4.75 root cube. What is the looseness factor? Looseness factor. Actual curved length divided by straight line length is called looseness factor. What is the degree of tortuosity or degree of sinuosity? Sinuosity, SINUOSITY. When do you go for rock dams, rock fill dams? When you go for arch dams? In which situation, what is the stabilizing parameter? Something about dams in general. Components in the water power engineering. 4-bay. Water approaching zone is called 4-bay. Trash rack. Penstock pipeline. Anchor blocks. Number of tail race. You should be thorough with all these things. In the Monday's class, we will solve some important expected questions. We will see what best we will do. This is the general strategy I have given. Subtopics, you have to concentrate. Don't spend too much time. If you are a GATE aspirant, allot minimum time only for GATE preparation. If you are a ESE student, you must prepare A to Z. There is no excuse. With this, I am closing. And good luck to one and all. And we meet on Monday evening, 7 a.m. Thank you. Abhisarana.